Hello, welcome back. When I last left you, we'd built a program that allowed us to control our color changing circuit. And if you remember, our light was oscillating between the different colors, red, yellow, white, and so on and so forth. I challenged you to write a program that took that same code and simplified it using functions. Let's give it a go and see how you got on. So I'm going to bring up the code window. Here is the program I left you with last time. If you remember, we had defined our pins. We had set everything up as outputs. And then we were simply turning on one pin after another. Now in our new program, all this stuff at the top here, it's going to be the same. So let's copy that, bring in a new sketch, and paste it. Now if we're going to define a new function, we've got to first of all decide what our function is going to do. In a good computational thinking design, one function does one job and one job only. So in this particular case, our function is going to set color. So let's call our function set color. So set color. Now I'm going to use an English spelling, but if you want to use the American, you can do. Be aware, most of the time computer programmers write in American English for things like color. Some languages don't really care between whether you use OUR or just OR, but I'm going to talk about OUR here. Just be careful if you're typing. Now, when we set the color of an LED, we need to send it 3 values. We need to send it a red value, a green value, and a blue value. So I'm going to open a bracket. And these are going to be integers. So int, let's give it a name. Because we've got R, G, and B defined above, I don't want to use exactly the same letters. So I'm actually going to use the word red. Then we have another integer, GRN for green, and another integer, BLU for blue. Then we open our curly brace and press enter, and we have the outline of a new function. What we haven't done is we haven't done the same as up here. We haven't told it what type of data is coming back. We'll have to do that at the end. We have to decide what's going to happen. So we're going to take in 3 numbers, a red, a green, and a blue, and we're going to set our color. So if these numbers are 0 and 1, if you remember, we can use 0s and 1s as alternatives for highs and lows. So we could simply just do digital write the red pin with whatever value came in on red. So whatever number we send in here, whether it's if we send a 0, it will say digital write to pin R0. If we send in a 1, we'll put a 1 in here, it will replace digital write R1. Let's copy that twice, and we'll set G to GRN and B to BLU. Now, I'm looking at this and thinking, we don't need to send anything back. So if we're not telling the main program we've done anything, we can just write the word void. So this function is called set color. It takes 3 inputs: an integer, a number for red, and we know it's going to be 0 or 1. Same for green, same for blue. And then it's going to control the output pins and return void. So, in our loop, to make our LED change colors now, all we have to do is write set color, and then we put in the code for whatever color we want. So if we wanted cyan, cyan is a mixture of green and blue. So the code would be 0 for red, 1 for green, 1 for blue. We can then wait, delay. Let's delay for 2 seconds. And then we can set another color. This time maybe we'll go from cyan straight to magenta. Magenta is pink, remember? It's the red and the blue. So that would be 1 for red, 0 for green, 1 for blue. I'm going to delay this time for 1 second. And then I'm going to jump immediately to blue. Set color blue. Blue is 0, 0, 1 because it's got no red, no green, and only blue. Delay 3 seconds, 3000 milliseconds. And then I'm going to turn it off. Off will be 0, 0, 0. And then I'm going to wait half a second, 500 milliseconds. And it can go around again. So again, I'm going to show you the overhead board. But let's check this verifies first. No errors. Upload. So let's have a look at the board. And I'll turn the light off. So let's have a look what we've got. Off, cyan, magenta, blue. Off, cyan, magenta, blue. Off, off. Lights coming on. Our code is still not perfect, but it's getting better. What we've now got is the ability to set any one of our 8 colors. And in doing so, we can set them in whatever order we want. We can set whatever delays we want in between. This is going to work quite nicely. I wonder if there's a better way of doing this. If you can think of another way we can do this. Have a think about it. I wonder if we can save some of our repetitive code. At the moment, we have set color, delay, set color, delay. I wonder if there's a way we can make that a little bit tidier, a little bit neater. But at the moment we have 28 lines of code, and we can set any color we want so long as it's one of the 8 basic colors. I wonder if there's a way we might be able to set these to 0.5. I wonder what that would do. Why don't you give it a try and see what happens if you say digital write 0.5. Let's see what happens. I'll leave that as an exercise for you to play with. In the next video, I'm going to talk to you about how we can get any color rather than just those 8. We're going to try and make this a bit more flexible. So, until next time, have fun, experiment, and I'll see you later.